So we have looked at hourglass triangles, bow tie triangles, we've looked at resolving vectors, so now let's try some problems. These next three problems that you're going to be looking at deal with your finding resultant worksheet that you will be completing. So looking at this first question here, it says an archaeologist climbs the Great Pyramid of Giza, which has a height of 136 meters, so that would be a Y, and a width, that would be like an X, of 2.30 times 10 to the second meters. Calculate the magnitude and direction of the displacement of an archaeologist after climbing from the bottom of the pyramid to the top of the pyramid. So you are trying to figure out your resultant displacement. So let's just call this x sub r, resultant displacement. Obviously that will be in meters, and theta equals, I don't know, and that'll be in degrees. So think about what the pyramid looks like, guys. It looks like this, right? So what do you really want to do? One of those variables, either your y or your x, is not currently correct. The one that's not currently correct is, I want just a triangle, right? So I need you to cut this guy in half. So really what you want to use is 230 divided by 2. 230 divided by 2 should be 115 meters. That's really what you want to use in your math. So from that, so what you really want to draw for your picture now, remember we're kind of in I guess now, I standing for the image, is this way and this way to climb up the side of the triangle. Theta is between resultant and first vector drawn. This is your x side of the triangle, y side of the triangle, and this is x sub r that you'll be solving for. So with that in mind, to figure out the magnitude, that would be the square root of x squared plus y squared equals r, in this case x sub r. So that would be the square root of 115 squared plus 136 squared. Please put that in your calculator and see what your calculator answer is. 115 squared plus 136 squared equals square root second answer equals. That should give you roughly 178 on your calculator. So from that, looking at your givens, you do want 3 sig figs. So 178 meters is your resultant's magnitude. Okay, what about the resultant's direction? So that means that you want to use tangent, theta, like inverse tan equals theta, and you want opposite over adjacent. So check out who's opposite and who is adjacent. And then assess, is this a bow tie or is this an hourglass? Well, it is a bow tie triangle. So since it is a bow tie triangle, that means that you want theta to equal the inverse tan of y over x. That gives us the inverse tan of 136 divided by 115. Make sure you're in degrees and not radians, and check this out. So 136 divided by 115 times the inverse tan, or inverse tan parentheses 136 over 115 end parenthesis equals. That should give your calculator roughly 49.8, and you only want, sorry about that, and you only want 3 sig figs. So therefore your final answer is 49.8 degrees. Locks it, and let's move on to the next one. Okay, solving for the sides of the triangle. When you solve for the sides of the triangle, you want to assess your x and y components on the diagram and solve for them by using the sine and the cosine function. So if you're going to use the sine function, that means that you're talking about opposite over hypotenuse. If you want to use the cosine function, that would mean adjacent over hypotenuse. Now notice here that I am saying that you're going to use sine theta for the y component and you're going to use cosine theta for the x component. This is only true of bow tie triangles. Because stop and think about it. Sine means opposite over adjacent. So if you have, opposite over hypotenuse. So if you have your opposite side, and obviously your hypotenuse, your resultant is going to be given to you, then that would mean that you're using the sine function. But what if you were given the adjacent and the hypotenuse? Well, if you're given the adjacent and the hypotenuse, then that would be the cosine function, right? But those are for bow tie triangles. So let me erase that and write something different in here. Stop and think what the equation then would be for the hourglass triangles. So for hourglass, you're going to use sine theta for the x component, and you're going to use cosine theta for the y component. Now, I know I'm going to get into this, but I kind of want to just jump right now and insert a new page so that we can chat about this for a second. Okay, so really what we're saying here is, here's the triangle that you guys are drawing, and your resultant side is now your given. So now your x is I don't know, and your y is I don't know. So you have to kind of assess from here. If you want to solve for the x side, that would be adjacent, right? So think about adjacent and hypotenuse. Out of SOHCAHTOA, who is adjacent and hypotenuse? That would be the cosine function. So cosine theta equals your x adjacent over your given, your hypotenuse. But you want to solve for just the x side. So your equation is cosine theta times your given, which is your resultant, is going to equal your x component. Make sense? So this is the equation that you would want to use. Now, this is not the original though. This is not going to be like the E in the guess method. The E in the guess method, we're going to dress it up a little bit, and we're going to say the x component equals cosine theta times your resultant, which once again, the resultant is what is given to you. Okay, so then obviously what would it be if it was the y component then that you were solving for? So the y component then would be, this is cosine, this is sine, because it's opposite now. So this would be sine theta times your resultant. Okay, now that's for bow tie triangles. For hourglass triangles then, what you're going to do is just like the opposite, right? Because now your x is opposite and your y is adjacent. So now if you were solving for your y component is adjacent, so that would mean cosine theta times resultant. And your x component is now opposite, so opposite is sine theta times resultant. And that's how you would resolve vectors. So in other words, you're working from the resultant side to resolve, well, what were my x and y components to get me to this angle of, at a degree of, for a distance of. Okay, let's jump back into the notes here then. So on this slide here, the only thing that I really wanted to assess with you guys is then which one is your y component and which one is your x component. Your y components consist of north and south, or up and down, or forward and backward. And your x components consist of east or west, left or right. And so for instance, this would be a triangle that you could draw to then figure out what is my resultant side. 11 squared plus 11 squared, square root that. That would give you a resultant side of the triangle. Okay, next. So this is going to be resolving vectors. So looking at this, it says the resultant side, and this is a velocity resultant, is 95 kilometers per hour, and theta is 35 degrees with respect to the ground. So if you have respect with the ground, then you are moving from the ground up when you're drawing your triangle. If you have respect to the ground, then just, to the ground like this, not with respect to the ground. And then that means that you're like flying and you're about to land. Okay, so with that in mind, what we're trying to solve is your v sub x and your v sub y. Agreed? Because you want to resolve the vectors. And you're going to solve for both of them in kilometers per hour. Okay, so with respect to the ground, so you're going up. So what that would mean is that here is your resultant, and you had to travel this way to figure this triangle out. You did not travel this way, nor did you travel, oh gosh, I can't even draw it wrong, to be honest with you guys. You didn't travel this way, then this way, I guess is what I'm trying to say. So you did not create an hourglass triangle. It's going to be a bow tie triangle. So with that in mind, let's draw in what we know so far. Here is your x that you're solving for. Here's your y, v sub x. And here is your v sub r that you already know. What I like to do at this point is just kind of remind myself that when I do solve for them, they should be positive quantities because you're heading towards the east and you're also heading north. Okay, so let's solve for the x component first. Well, once again, we already know that this is a bow tie triangle. And since this is a bow tie triangle, that means that your x is going to deal with cosine theta times your resultant. And then your y is going to be sine theta times your resultant. Making sure that you are in degrees, please calculate the cosine of 35 times 95. Cosine of 35 times 95. That should give you about 78, whereas looking at your givens, that's exactly what you want. You want your v sub x to equal 78 kilometers per hour. Okay, so then for your v sub y, now you're dealing with the sine function. So that would be the sine of 35 times 95. And the sine of 35 times 95 is 54. So your v sub y equals 54 kilometers per hour. Yay, you just resolved vectors. So that's also in your finding vectors and resultants worksheet. Excuse me. Okay, so on this, you're going to break into your different components, and this is like day 1, day 2 stuff. So this is the tail end of the problems that I want to work with you on. So for this one, you're going to have to solve for x1, x2, y1, y2, get your x total, get your y total, and then you can do Pythagorean theorem and inverse tan. So from that, I'm going to skip this problem because you were already given your x and y for day 1 stuff, and don't worry so much about it. So just kind of skip this page. This is more so like a review of the very, very first ones where, okay, how would you solve for your resultant? It's just looking at the setup. This is the one that I really want to deal with. And now I'm always going to refer to these as day 1, day 2 problems because that sample problem right here does say day 1, day 2. So what you need to do is saying, okay, so the hiker, this is arbitrary, don't read the question yet. So the hiker went this way and the hiker went that way. Well, the hiker could have just simply done this, solve for just simply doing that. But the way to do that is you have to figure out x1 and y1, then you have to figure out x2 and y2, and then you have to get your x total, your y total, and then you have to draw your new triangle, and then you can do Pythagorean theorem and inverse tan to figure out the final answer. So that's kind of like the format that we're going to use. So let's break this whole guy down. And then this should wrap up your finding resultants worksheet. Okay, I am going to start this problem specifically on the next video because we are about to run out of time here. So once again, what your setup should be is write down day 1 information, write down day 2 information, figure out x1, figure out y1, figure out x2, figure out y2, get x total, get y total, then draw your new triangle. Based off of that new triangle, x total on this axis, y total on that axis, then you can solve for your resultant and your theta. All right, so we'll catch you on the part 4 video.